Hello everyone, welcome back to my study. In this video, I am going to find an analytic function of the form f of z is equal to u plus iv when u minus v is given to us. Also, there is a condition f of pi by 2 is equal to 0. So, let's start to solve this question. Before going to the solution, if you like the content, please subscribe my channel and like the video. Given u minus v equal to cos x plus sin x minus e raised to minus 5 all divided by 2 cos x minus e raised to y minus e raised to minus y. So we know that e raised to y plus e raised to minus y divided by 2 is cos hy, hyperbolic function of cos. So e raised to y plus e raised to minus y is 2 cos hy. So we can write it as cos x plus sin x minus e raised to minus y divided by, this is minus of 2 cos hy. So we can take 2 as common. So cos x minus cos hy. So this is our u minus v. So we need to find an analytic function f of z equal to u plus iv. It's in the form u plus iv, where u is the real part and v is the imaginary part. To solve this problem, we use CR equation, that means Cauchy-Riemann equation, that is ux is equal to vy and uy is equal to minus vx. And in order to find the analytic function f of z, we use Milne-Thomson method. So let's start solving the problem. So let's differentiate u minus v with respect to x and y partially. We are now differentiating the u minus v with respect to x and then y partially. That means we are finding ux minus vx with respect to x, u minus v, ux minus vx. Now with respect to x, derivative of that is in the form u divided by v. So we need to consider denominator into derivative of numerator and minus numerator into derivative of denominator divided by denominator square. So the denominator is 2 into cos x minus cos hy. Now derivative of numerator. Cos x derivative with respect to x. Cos x derivative is sin x, minus sin x. Plus sin x derivative is cos x, and now there is e raised to minus y, which is a function of y, so derivative is 0, minus numerator is cos x plus sin x minus e raised to minus y into derivative of denominator is 2 into cos x minus cos hy. Its derivative is minus sin x and cos hy is a function of y, so derivative is 0, and divided by derivative square, that means 2 cos x minus cos hy all square. This 2 square is 4. Now let's multiply this. This is minus 2 sin x cos x This is so lengthy. Minus 2 sin x cos x, and this is plus 2 cos hy sin x, and plus 2 cos square x, and plus 2 cos hy cos x, and plus 2 cos x sin x, and plus 2 sin square x, and minus 2 e raised to minus y sin x. This is numerator, and denominator is 4 cos x minus cos hy whole square. So this term cancel, minus 2 sin x cos x and plus 2 cos x sin x is cancelled. And look at this terms, 2 cos square x plus 2 sin square x. We know that cos square x plus sin square x is 1. So this term become 2. And this is 2 cos hy sin x and 2 cos hy cos x. So finally we get 2 cos hy, we can take it as common, sin x plus cos x, and there is a 2, and minus 2 e raised to minus y sin x. Also we can cancel this 2 with this 4. So we get 2 cos hy sin x plus cos x, and this is 1. So what we get? This is 1 divided by 2 into cos x minus cos hy whole square. So this is ux minus vx. Now let's differentiate partially with respect to y. That means uy minus vy. Sorry, this is minus 2 cos hy cos x. Let's correct. This is minus 2 cos hy cos x. So this becomes sin x minus cos x. So cos hy sin x minus cos x plus 1 minus e raised to minus y sin x divided by 2 into cos x minus cos hy whole square is our ux minus vx. Now let's calculate uy minus vy. Uy minus vy. Similarly, uy minus vy is denominator 2 cos x minus cos hy into derivative of numerator. There is only the function of y is e raised to minus y, and there is a minus, and minus e raised to minus y into derivative this into minus 1. So minus minus cancel, and minus of numerator is cos x plus sin x minus e raised to minus y into derivative is minus 2 sin hy. Cos hy derivative is sin hy, and there is a minus 2 outside, divided by denominator square is same, 4 cos x minus cos hy all square. So we get uy minus vy as, let's 2 cos x minus cos hy e raised to minus y plus 2 sin hy. Also we can cancel this 2 from numerator and denominator. So we get plus sin hy cos x plus sin x minus e raised to minus y all divided by 2 into cos x minus cos hy all square. So this is our uy minus vy, e raised to minus y cos x minus cos hy plus sin hy cos x plus sin x minus e raised to minus y. Now we use CR equation. CR equation is ux is equal to vy and uy is equal to minus vx. So let's rewrite this ux minus vx and uy minus vi. So ux minus vx is this and uy minus vy. Let's call it as 1 and equation 2. Now this is, we can use CR equation in 2. First use CR equation in 2. That is, we know that ux is equal to vy and uy equal to minus vx. So this is uy is minus vx minus vy is ux. So this is equal to minus vx minus ux and this is half into this equation, same equation. And we replace uy equal to minus vx and vy equal to ux. And now let's look at 1 and this equation is 3. Let's call it as 3. Now let's look at 1 and 3. We can calculate Vx or Ux, either Vx or Ux. This is Ux minus Vx and this is minus Vx minus Ux. So I am adding 1 and 3 so that I can cancel ux from this equation. Ux minus ux is cancelled and we get minus 2vx equal to half into, half is common to both 1 and 3. So half into cos hy sin x minus cos x plus 1 minus sin x e raised to minus y plus e raised to minus y cos x minus cos hy plus sin hy cos x plus sin x minus e raised to minus y. I added 1 and 3 and the common denominator is there, that is cos x minus cos hy all square. So this is minus 2vx. So vx is, we get vx as, so vx is equal to minus 1 by 4 and that term cos hy sin x minus cos x plus 1 minus sin x into e raised to minus y plus e raised to minus y into cos x minus cos hy plus sin hy into cos x plus sin x minus e raised to minus y divided by denominator is cos x minus cos hy all square. Now we get vx. Now what is vy? If we find vy, then we can use Milne Thomson method to find f of z. So let's find vy. For that, I am using CR equation in equation 1. That is, we get, what is equation 1? This is ux minus vx. We can use ux is equal to vy and vx is equal to minus vx is uy. We can use CR equation here. So we get Vy plus Uy equal to that equation 1. Equation 1 is Vy plus Uy. We use ER equation in equation 1. So 1 by 2, what is equation 1? Cos Hy into sin x cos x plus 1 minus sin x e raised to minus y all divided by cos x minus cos Hy all square. This is our equation 1, and now let it be equation 4. This is our equation 1. We use only the CR equation. Ux is equal to Vy and Uy equal to minus Vx, so that it become a new equation. So let it be 4. Now we get Vy from this equation 4 and equation 2. Comparing equation 2 and 4, I am minusing 4 minus 2. What we get? 4 minus 2. Equation 2 is, this is our equation 2. If we minus 4 minus 2 from 4, we get Vy there and Uy will be cancelled. So 4 minus 2, we get 2 into Vy equal to half is common and cos Hy sin x minus cos x plus 1 minus sin x e raised to minus y. Note this minus. So we get plus minus e raised to minus y into cos x minus cos Hy. And next term becomes minus sin Hy into cos x plus sin x minus e raised to minus y. This is our whole term, and denominator is common. Denominator is cos x minus cos Hy whole square. So then Vy is, take this 2 here, Vy is, so Vy equal to 1 by 4 into cos Hy sin x minus cos x plus 1 minus sin x e raised to minus y minus e raised to minus y into cos x minus cos Hy minus sin Hy into cos x plus sin x minus e raised to minus y. This is numerator and denominator is cos x minus cos Hy all square. So we get Vx and Vy. We can use Milne-Thomson method to find our f of z. What is Milne-Thomson method? In this method, we replace x is equal to z and y is equal to 0. So we get f of z equal to integral Vy. This is in terms of v. So Vy, remember this equation, integral f of z is equal to, if we have v with us, we have Vx and Vy. only Vx and Vy. Then we can use the equation as f of z is equal to integral of Vy of z0 plus I into Vx of z0 dz. This is Milne-Thomson method to find f of z. If we have ux and uy, then it becomes f of z is equal to integral of ux at z0 plus minus I uy at z0 dz. So this is Milne-Thomson method. If you have any doubt, please watch my previous video related to this Milne-Thomson method and many problems related to this. So here we have Vx and Vy. So I use this equation, f of z is equal to integral of Vy at z0 plus I Vx at z0 dz. So what is Vy at z0? So this is Vy. So let's find Vy at z0 and Vx at z0. Vy at z, 0. Put z equal to, x is equal to z and y is equal to 0. So we get 1 by 4 into, this is cos h0, y equal to 0, cos h0 is 1 and sin z minus cos z, sin z minus cos z plus 1 and minus sin z, and this is e raised to minus 0, that is e raised to 0, this is 1 and minus again e raised to 0 is 1 minus cos z minus cos h0 is 1 and this is sin h0 into any term. Sin h0 is 0 and this is 0 into some term is always 0. So neglect that term. What is denominator? Denominator is cos z minus cos h0 is 1 all square. So this is our Vy at z0. We can cancel sin z here, sin z minus sin z, and this is 1 plus 1 and this is minus cos z minus cos z, that is minus 2 cos z. So finally we get Vy as Vy equal to minus 2 cos z plus 2 divided by cos z minus 1 whole square, and also there is a 1 by 4. We can cancel this 2, 2, 4. So finally we get 1 by 2 into 1 minus cos z divided by, we can write it as 1 minus cos z whole square. This is because a minus b whole square and b minus a whole square are same square term. So cos z minus 1 whole square and 1 minus cos z whole square is same. So we can cancel it with the numerator. So we get 1 by 2, 1 by 1 minus cos z. This is our Vy at z0. Now let's check what is Vx at z0. So this is our Vx. Cos h0 is 1 and here sin z minus cos z plus 1 and this is e raised to 0 1, also sin z, also we get cos z minus 1 and sin h0 is 0. What we get? Also in this Vx also this term, these all terms cancel only because of the sin h0. Sin h0 is 0. So what we get? 1 by 4 sin z minus cos z plus 1 minus sin z, e raised to 0 is 1 plus cos z minus 1 plus that term is 0. So plus 1 minus 1 cancel, cos z minus cos z cancel, sin z minus sin z cancel, so this is 0. So what is our f of z? F of z is integral of Vy at z0 dz only plus I into Vx is 0. So what we get? Integral of this is 1 by 2 into integral of 1 by 1 minus cos z dz. So what is 1 minus cos z? We can write it as, we know that cos 2z is 1 minus 2 sin square z. So 1 minus cos 2z is sin square 2 sin square z. So 1 minus cos z is, this is 2z, 1 minus cos z is 2 sin square z by 2. 1 minus cos z is 2 sin square z by 2. So substitute this term here. So what we get? 1 by 2 integral 1 by 1 minus cos z is 2 sin square z by 2 dz. Now substitute t for z by 2. Put t equal to z by 2 in order to integrate this. We need to integrate f of z equal to integral 1 by 2 integral 1 by 2. We can write 1 by 4. So this is sin square z by 2 dz. So put t equal to z by 2. What is dt? dt is equal to 1 by 2 dz. So we can write, also we can write it as 1 by 4 integral of 1 by sin square is cosec square z by 2. 1 by sin square is cosec square z by 2 dz. Now substitute the value 1 by 4 integral of cosec square z by 2 is t and dz is 1 by 2 into dt. 2 dt is dz. So 2, 4 cancel with 2, 1 by 2 integral of cosec square t. You know that integral of cosec square is minus cot. So this is minus cot t plus some integrating constant c. So what is final answer? Minus 1 by 2 cot t z by 2 plus integrating constant c. And we have given that f of pi by 2 equal to 0. So substituting this, f of pi by 2 is minus, this is our f of z. So minus 1 by 2 cot pi by 2 is pi by 4 plus c, this is equal to 0. We know that cot pi by 4 is 1. Cot pi by 4 is cos pi by 4 by sin pi by 4. This is 1. So minus 1 by 2 plus c equal to 0 means c is equal to 1 by 2. We got the constant z equal to 1 by 2. So the function becomes f of z is equal to 1 by 2 into minus cot z by 2 plus 1. C is 1 by 2. So take 1 by 2 outside. So f of z is 1 by 2 minus cot z by 2 plus 1. This is our analytic function. So in order to find an analytic function, if we have u minus v with us, let's differentiate partially with respect to x and y and find out either ux and uy, ux and uy, or vx and vy from this u minus derivative of u minus v with respect to x and y. Using CR equation, Cauchy-Riemann equation, we can find ux and uy or vx and vy. Then we use Milne-Thomson method to find the analytic function f of z. Hope you understand the solution. If you understand the solution, and comment your doubts below if any. Please subscribe and watch my videos. Thank you for watching.